All right, guys, thank you so much for coming today. We're going to review lectures 16 to 20 for the final exam 4. And it's all in chapter 11. So it's going to be all in the nervous system. So this should be okay for you guys in terms of the material you have to learn. This time I just introduced a new section. You'll probably like it because, yes, you will. Just hear me out. Okay, what I did is I added a section, another section, so that you have 4 sections in the exam. And it will be matching and sentence completion. So I give you the words to choose from. I give you a little more than you need. And then you pick the correct words, okay? And you dump them in there. So that's number 1, which is a little better, because then you have something to work with. Okay, so and therefore that reduced the long answer questions, which you guys don't really like a lot. So you have 3 out of 5. You see what I'm saying? So I'm hooking you up, guys. But it's still 60 points as usual. You will have 25 questions in the multiple choice section, which is better, slightly less than what we're used to. So exam format. I just wanted to say that so that when I write it down here, you guys won't be shocked. It's all good for you guys. So exam format. So we get section 1, which is our usual multiple choice. All right. And here we will have 25 times 1, which equals to 25 points. All right. And then the new one, section 2. Which I like to call matching, because you pick and you match with each number or each question with a set of words and so forth. So you pick from a group of words. Sentence completion, and I give a description for a term, and then you pick out the word that fits that description. So you have 5 of that times 1, plus then the sentence completion 5 times 1, which is 10 points, right? And then now it's all same as usual. Section 3, all right, will be the usual short answer questions, all right? And you will have the usual 5 of 6, right? 2, which is 10 points. And then the final section, 4, will be the long answer questions, which will be 3, and you get a choice of 5. So which kind of gives you more choice. Okay, so pick the ones you know best, times the usual 5 points, so equals 15. So that's 25, 35, and 60 points. Okay, so this section, please don't ever leave a blank. Even if you have no idea, put something there. Okay, I don't care what you do. If you just do something, because you miss points. You never know. You might just guess the right one. Okay, never do that. In multiple choice questions, always make sure you answer all of them, and not leave it blank and say I'll come back later to it, because you might not have time at the end. So rather put something, put a little mark on it, and then if you have time at the end, come back and check. Okay, because people lose points because they do that. They leave a multiple choice question and so forth. So please, guys, don't lose points unnecessarily. Yes.
How long do we have to take?
The exam is the usual 1 hour 15. Yeah, 1 hour 15. It's 1 period long. So, and it should be a little better for you, because those short answers, the section 2 matching really doesn't take much time, really, when you think about it, because you've got the words right there. The description will kind of remind you, and then you can pick the correct words. Chances are most likely you get the correct word. Okay, so that's why I say never leave those sections blank. Okay, so the first time we were talking about the spinal cord, all right, then we talked about reflexes, and we carried on like that. So here's the basic functions of the spinal cord to connect the peripheral nervous system to the central nervous system, right, to the brain. All right, and it also integrates information and it does reflexes. Connect cerebrum to PNS. Okay. Also, and it integrates information, processes slightly before it goes to the central control center, right? So those are the basic functions. You need to know the basic functions of the spinal cord. You know what I'm saying? And therefore, it does reflexes as well, right? Things that are automatically controlled. So those are the basic functions. So you need to know that. And the characteristics, it's a slender column, right? Okay, which is certain curvatures, right? Cervical curvature, lumbar curvature. Okay, it's not just a straight column, all right? And then it has those enlargements, okay? Remember, the enlargements coincide with what? With the nerves that supply the arms and the legs, right? The lumbar enlargement for the legs, the cervical enlargement for the arms, right? Remember we talked about it? So those things, those are sometimes I may say list a few characteristics of the spinal cord. You talk about that. The basic functions of the spinal cord. You talk about the integration. You talk about how it connects the upper parts of the brain with the peripheral nervous system, right? Okay. It's also covered by the meninges. Okay. So just know the structures that protect the spinal cord. So you've got the three meninges, all right? And it goes through the vertebral foramen, right? The vertebral foramen is made up of those vertebrae which are bone. So they have the periosteum, which is the membrane on the outside, right, or in the insides of bone, right? So the epidural space is the space between the dura mater and the periosteum. Okay, and that's full of fat to kind of cushion it, right? Okay, that's the epidural space, right? And then, so you've got the dura mater on the outside, and then you've got the arachnoid on the inside, and then the pia mater is innermost. Okay, and then the subarachnoid space is under the arachnoid, right? So know those spaces because they're important, right? What's under the subarachnoid space? What's in there? What's under the subarachnoid space? Some certain fluid called cerebrospinal fluid, okay? Because I want you to know those spaces and what's in there, okay? And we talked about it. This is where anesthetic is deposited in the epidural space. Especially during childbirth, they numb the lower part of the body, okay? And they deposit the anesthetic in the epidural space. So I want you to know those spaces and so what are some of these uses, okay? Sometimes I sprinkle this in multiple choice questions, okay? And then know the dura mater, the pia mater, and the arachnoid, which are the meninges that protect the spinal cord, and these continue to the brain too. We will cover that when we do the brain. Okay, so gotta know those qualities. Okay, in the spinal cord section, cross section, when you take a cut on it across, when you get the white meat on the outside. Okay, and I'll have multiple choice questions that mention these things. Ask about the arrangement of the spinal cord. Material. So you get the white matter on the outside and the gray matter on the inside. Okay, because the gray matter then is got so the white matter outside, and it's arranged in what we call columns because what is myelinated? Axons. Axons are just the fibers of the neurons. Okay, so those fibers run up and down the spinal cord, carrying information to the brain. So those are ascending tracts carrying information down
to the body parts which are descending tracts, okay, which are motor and sensory. Okay, so they are arranged in sub-bundles, columns, called funiculi. Okay, and then smaller sub-bundles called fasciculi, right? Okay, fasciculi. These are all spelled in the book. Okay, fasciculi, and then on the inside, you've got those horns. The gray matter is kind of arranged. So you know what I'm saying? Here's the deal. It's almost like a heart thing. Okay. Okay, so there's 3 horns. Each half is divided into 3 horns, right? See what I'm saying? That's the gray matter part. It's divided into the horns. Okay, and we said this is where the dorsal root comes in. Okay, and the dorsal root is sensory, carrying information to the spinal cord, right? So the cell body is here on the dorsal horn. See, which is, so there's the dorsal horn, because I need you to know these horns and what's in there. It carries the sensory bodies for, the neuron cell body for sensory neurons, right? Which will then usually connect to an interneuron, okay? All right, so, because I'm going to ask about these horns. I'll sprinkle it all over the multiple choice questions, all right? And that's the gray matter on the inside of the spinal cord, flanked or surrounded by the white matter on the outside, okay? And then these lateral horns, okay, these ones carry sensory, okay? Because this is the dorsal horn here, which is the dorsal root ganglion right there, okay? So these are the lateral ones. These ones, okay, and they carry motor to, to the for everything that's automatically controlled for the autonomic nervous system, parasympathetic and so on, okay? Anything that's automatically controlled, so it's carrying motor. So those are the cell bodies of motor neurons to the parasympathetic autonomic nervous system, okay? And remember, we said on the bottom would be the ventral root, which we say is a motor, because it's carrying information away from the spinal cord to control the body parts, right? So the ventral horn, also sometimes called the anterior horn, right? Because it's up here, all right? The ventral horn will have cell bodies of motor neurons, somatic motor neurons, okay? Ventral horn, all right? Do you see that, guys? Ventral horns will carry somatic motor. The lateral is autonomic motor or parasympathetic nervous system. You see what I'm saying? See the difference now? Because I will ask about these horns all over the place in the multiple choice. So you have to know which one it is. Just remember, the dorsal horn is sensory. The ventral, horn would be somatic motor, because that's where the motor neurons come from. Okay? Because the cell bodies of these neurons are located in the middle of the spine, and cell bodies are not myelinated, so it's going to be gray matter. Okay, and the axons are myelinated on the outside, and that's white matter. Okay, all right, guys. And then we talked about commissural fibers, that kind of join, the left and the right side of the spine. Commissural means to connect. Okay, whenever we talk about commissural, anything in the nervous system is connecting to 2 sides. Okay, so that's the last part. Then you have commissural fibers. Okay, so gotta know these gray horns and how the gray matter is arranged in the spinal cord, and gotta know the white matter and how the white matter is arranged in the spinal cord. All right, very good. All right, very good. Moving right along. The 2 major divisions of the nervous system as a whole. I think I had one of these questions in one of these exams. you know, people were talking about autonomic and parasympathetic. That's way down there. Okay? The two major divisions are the central nervous system and the peripheral nervous system. Okay? For this whole thing. For the whole nervous system. Okay? Autonomic is a sub division way down there. Okay? So, just know that, okay? You see where it is? All the way down yonder. Okay? So, gotta know these main stuff. And this is made up of the peripheral nerves, right? The spinal nerves, cranial nerves. Okay? And then the CNS is made up of what and what? Yeah. You see what I'm saying? Okay, guys? So remember how the nervous system is organized. You need to know that, okay? And then, of course, the peripheral is one that's divided into sensory and motor. And then, of course, somatic. And autonomic is the motor division. All right? That's when we're talking about those somatic motor neuron horn, you know, which is the ventral horn. And then the one that, the motor neurons that control the autonomic, like the parasympathetic and so forth, is in the lateral horn of the granite of the spinal cord. All right? That's kind of on the side. And then the dorsal horn is the sensory, right? Okay, good. And these divisions, of course, the enteric does that. All right. Spinal cord cross section. Of course, the dorsal and the ventral roots don't just start as a root from the spine. They start off as rootlets like this, right? And then those rootlets join, right? Again, if I draw my little spine here, okay? So it comes like that. See those rootlets? Remember those rootlets? You see what I'm saying? And then they join together here. Okay? And then the dorsal root, there's a ganglion right there. Because the incoming neuron will synapse with another one before it enters the spine. Okay? So this is going this way. So the dorsal root is sensory, right? The ventral root is motor. Okay? Because it's conducting information away like that. Okay? And then we've got our horns here. Okay? There you go. Right? Dorsal horn, lateral horn, ventral horn. Okay? So, I gotta remember that because I'm going to ask for those. And then, because the spinal nerves contain motor going to the body parts and sensory going to the brain, it's mixed. It's mixed. It's a mixed nerve. Okay, so what is a spinal nerve? The union of the dorsal and ventral roots, right? Okay, very good. So, reflexes. What is the definition of a reflex? These are kind of sort of stereotypical, you know, and they are automatically controlled responses to stimuli. Yeah, involuntary. So they are automatically controlled. You don't have to think about it right now. If the way I'm standing right now is because the stretch reflex is causing my legs to remain straight. Okay? And I don't need to think about that because right now I'm trying to teach you guys right now. So it will be too much for me to be trying to think about this. So that's why you have reflexes to carry on with automatic things so that you know you can focus on other things. Okay, so these are automatically controlled responses to stimuli, right? Okay, so and the functions, you know, there's several, you know, like, you know, reduce tissue damage, you know, and all those things. Yeah, maintain homeostasis. Okay, and actually the reflex arc is the you know, basic unit of the functional unit of the nervous system, because it includes all the components of the nervous system that can do something, that can do a job. Okay, so it's the least amount of components that you need in the nervous system to do something. Okay? Okay, guys? So, and these things are in there. So you've got two types of reflexes. Some are somatic, and these ones include like the muscles, like removing your finger from a painful stimuli, okay, responding to an outside force, like if I was to punch you, you wouldn't fall forward. The reflex is to fall backwards to kind of absorb the punch, okay. All those things that involve muscles, reflexes that involve muscles, are somatic reflexes, okay. And then there are automatic reflexes, usually that control, you know, soft internal organs and things like that, you know, you know, so this is usually viscera and stuff, and this is usually muscles, skeletal muscle, okay? And the biggest thing is removing body parts from painful stimuli, and then you have to contract your muscles. So those are the two general types of reflexes. And then, like I was saying, the reflex axis is the functional unit of the nervous system. Why? Because it includes all the components of the nervous system that are necessary to do a job. Like you need a receptor to tell you the information, and then you need the central control unit, the brain, to make sense of that, and then generate a response. And then you need the effectors like muscles to do the job. So the reflex arc includes all those things, and of course sensory neurons and motor neurons, right? So that's the fewest things you need when we talk about a functional unit. Is the fewest things you need from that part to make it work, to do the job. Okay? So we got the steps, because you know you need to know this. Sometimes, you know, at 5-point I might say, oh, can you do the reflex arc, you know, tell me about the reflex arc and what's in it. So receptor, sensory neuron, right? And then yeah, sometimes even interneuron and so forth. But the basic components, when you have complicated reflexes, then you have an interneuron. But the basic components you need to do something, which is the basic functional unit. Then there's the control center, right? That you know, determines what to do and what to make sense of the information that's being sent to it. And then you need a motor neuron, right? That will take the information to the effectors like muscles, glands, and so forth. Right? Effectors. Okay? So know those steps in the reflex arc and the components, the major components being the central nervous system, the effector, and the receptor. Okay? Gonna know that there's 5-point question. All right, there you go. You know, the spinal cord, you know, is controlled back and forth. You know, remember we talked about the funiculi, fasciculi, those tracts going up and down. Okay, they are ascending tracts and descending tracts that come and unite. You know, convergent, meaning several neurons will come and converge onto one, and then will carry information from different parts of the nervous system. Having fun, my good friend over there. And then divergent is like a few, one neuron, and then will diverge and synapse with many others. So carry information to many parts of the brain, things like that. So the brain will, of course, edit these responses, these reflexes, okay? Because it's got the final say, it's the control center. It will either accentuate or suppress certain reflexes, depending on the need, okay? So the brain does that. All right? And then we need to know these reflexes, and we need to know pretty much, you know, the reflex arc part of it, what it includes, whether it includes interneurons or not, or in fact, the stretch reflex, which is causing me to stand upright, is the simplest of all, because all it has is a sensory neuron, and it synapses directly with the motor neuron. Okay? So that's the simplest reflex. Okay? Simplest. Okay, and you know, the kind of receptors in there, stretch receptors, okay, muscle spindle. For each of these, I need you to know the kind of receptor that is responsible for this reflex. The muscle spindle, okay, it's located in the muscles. It gauges the stretch of the muscle. So if the muscle is stretched, it will automatically contract. Okay, like that's why the patellar reflex is stretched. If I do this, you see, even I can do it by myself standing up like that. You know, by pulling on this tendon that attaches to these muscles, you stretch them. So when you hit it, it will cause the muscle to contract. It opposes that. You see what I'm saying? So that's why you need to know the function of that. And the function is, of course, you know, to create upright posture, right? So you can stand up straight. All right? That's the stretch reflex. Okay? Golgi tendon reflex. Golgi tendon organs. Is the kind of receptor that, and the receptor is located in the tendon, right? The name tells you too. Okay? It's located in the tendon. What's the purpose of this? When your muscle is contracting, it pulls on the tendons. Like if you're trying to bench press 300 pounds, you see what I'm saying? It's going to really, because your muscle has to contract a lot, so it's going to pull on the tendon which is attached to the bone. So in order that you do not break the tendon off the bone, which would really suck, because it will take a lot to fix. Okay, so the body has a reflex for that, so that if you're too idiotic to lift too much weight or to over-exert your muscles, it will cause the muscle to relax, so that it doesn't keep yanking itself from the bone. So that's the purpose of this Golgi tendon reflex. Okay, and this one has got interneurons. It's a little bit more complex. We're working our way up. Okay? You see the purpose of this one? To prevent damage to tendons, detaching them from the muscle. So when the muscle is contracting, it will cause the muscle to relax. Okay? To reduce that tension on the tendons. Okay, so that's that one. And it's the Golgi tendon organs which are located in the tendons. Okay? And the withdrawal reflex. Okay, this says it. If I was barefooted right now, I'm walking on the beach, I step on a very sharp, what do you call it, a shell. Okay, and boom, I do that. That's withdrawing your, leg from painful stimuli. This would be a good example of a somatic reflex, right? Because you have to yank your leg away from there. If I was to touch a hot plate by mistake, let's say somebody in the house switched on a stove and I didn't realize it, and then I touched, oh my God, because I would have to do that. I would have to withdraw. Okay, so that's what it limits tissue damage, right? You see what I'm saying? Because if I keep my hand on the hot plate, it's going to start going through, and then they will be left with a stump. Okay, and then I'll need my hand. So it limits tissue damage, okay, it's more complicated as well. It's got interneurons, and then of course those descending and ascending tracts that connect the brain. This one was not in your list, but I added it because the withdrawal reflex usually happens with a stretch reflex on the other side of the body. Because most of the time, let's say if I'm standing and my left leg steps on the tack or the sharp shell, okay, I'm going to need all my body weight on my right side. So it is a much more complicated, because it will, on the left side is doing the withdrawal, the left leg that's stepping on the tack. On the right leg is causing the stretch reflex so that it will maintain the body weight. Okay, so that's a much more complicated, with a whole bunch of interneurons and so forth. You know what I'm saying? That crisscross from one side where you start to use those commissural fibers that connect the left and right side. Okay, I just wanted to add it for you guys so that you can see how complex it can get. Okay, with these reflexes. Okay, so gotta know these reflexes, gotta know the functions and the nerves and plexuses, and also the receptors. There you go. spindles. So we talked about spinal nerves and spinal cord, and now we're going to talk about the nerve structure itself and how those nerves are arranged. Okay, that's where we're going to come into plexuses, which are very complex networks formed by those anterior branches, or the anterior rami of the spinal nerves. So just like I said with muscles, it's got certain connective tissue. I need you to know these connective tissues because I'll sprinkle it in multiple choice and say, okay, this connective tissue divides a nerve into small groups called fascicles, which one it is, and then you say the perineurium. Okay? So this one, for sub-bundles, okay? They're covered by perineurium. Endoneurium covers like the myelin sheath or the Schwann cells and the oligodendrocytes covering the neuron, and it covers immediately. So this is the fiber, okay, and this is the myelin sheath, myelin sheath, myelin sheath, okay. So the first membrane is the endoneurium, okay. So that's the endoneurium, and then little bundles of these fibers, which are axons, right? Axons of the neurons. Some small bundles called fascicles are covered by the perineurium. Okay? So this will be the whole nerve, and then this is the perineurium, like that. Okay? And inside of it, you will be the endoneurium. Okay? So the whole thing is covered by, on the outside, by the epineurium. Epi is on the outside, okay? So just know those connective tissue membranes and how they compartmentalize these nerves, right? So we get 31 nerves, right, coming out of the spine, right? And we need to know how many are in each of the regions, okay? Right? So, what's the first region? Up in the neck?
Cervical.
Okay, and how many are there?
8.
Okay, very good. And then we got the
Thoracic.
thoracic.
12.
Okay, and then we get the
Lumbar.
lumbar, which is lumbar is lower back, right?
5.
5, and then
Sacral.
sacral. 5, so that's 30. So we need one more, right?
Coccygeal. 1.
Okay, and that's 1. Okay, so it's not going to make it C0. Okay, so you guys got the regions good. If you ask that 5-point question, you get all the 5 points, right?
Yes.
Of course. So you need to know what dermatomes are, right? And we said these are units of skin, a certain area of skin that is innervated by a particular spinal nerve, right? You need to know this dermatome. Because, let's say for that, fill in the, the completion thing, that matching thing where I'll list a bunch of things and one of them will be dermatome, and then it will say blank is the area of skin that is controlled by a particular spinal nerve, and then you choose on your list dermatome, and then you put the letter that matches it, okay?
Thanks for doing that.
Yeah, you do understand. You might just get that question and then don't say I didn't tell you. Okay? So, you gotta know what the definition is. Alright? Okay, very good. Okay, we started with the rootlets from the spine. They join to form the dorsal and the ventral roots. Those dorsal and ventral roots join to form the spinal nerve. Okay? Now we got a spinal nerve. Now it's going to have to split up to provide, to supply parts at the back, parts at the front. That's where the rami comes in. Rami is a fancy word for branch, okay? When the spinal nerve comes out, it will branch into many different parts of the body, right? So don't be fooled by this rami, okay? It's just a branch, that's all it is. Spinal nerve will split up and then go to different parts of the body, that's all. So there's nothing fancy there. So the dorsum again means back. Dorsum is a Latin word meaning back. So the dorsal branch, which is the branch that goes to the back, is going to go to the back muscles, right?
So this is the branch of the spinal nerve that supplies the back. That's all it is. It's nothing fancy right there. Okay? The ventral, that's where we might get a little fancy, because the ventral is the anterior branch of the spinal nerve, or the anterior rami, or that will supply the front. And your business of you is right in the front of you. So it's going to be carrying a lot of nerves up in the front. Okay, makes sense? So that's where certain sections where the busy end is, you're going to have plexuses, which is a way to organize a whole bunch of these nerve networks. Okay, that's what's going to happen now. But there are certain parts, like in the torso here, there's really nothing busy going on here. You see that? It's just my chest and skin. So the intercostals, there are no plexuses there. From about T2 to T12, nothing. Because really, see, look at that. But over here, I got my arms, my hands, they feel, they touch. Here, I got my genitals, all those things. Need a bunch of nerve work. That's when you need the plexuses. Okay, so that's where they come in. So the ventral, in the thoracic, there's really nothing going on there, most of the thoracic region. But the ventral branches, or the anterior branches of spinal nerves that usually coincide with those enlargements we talked about, like the lumbar and cervical enlargements, that's where you have the plexuses. Right? So we get the cervical and the lumbar part. The lumbar is got to do the legs and so forth. Okay? So these are the branches of the spinal nerves. All right? So I need you to know all those branches and what they're doing, what they're carrying, because I might just sprinkle that one place. Then we get the communicating rami. I talked about it last time. The spinal cord is next door, and then you've got sympathetic chain that is parallel to the spinal cord. That controls the sympathetic nervous system, okay? So those neurons that control the sympathetic node that's involved in fight, flight situations, okay, they synapse right outside of the spine in this called paravertebral chains. Okay, why? Because it's parallel to the vertebra. Okay, paravertebral chain is called the sympathetic chain. Okay, and the cell bodies of them are called ganglia, so it's called paravertebral ganglia for the sympathetic nervous system. So when a spinal nerve comes out of here from the spine, this is the spine, it will, for the sympathetic nervous system, remember we split up the nervous system at the beginning, okay? It will go to the sympathetic chain first, okay? So the branch of the spinal nerve that connects to this chain is called communicating rami. And the one that comes from the spinal nerve and connecting here, that's a white rami. It's myelinated, okay? So it's called the white communicating rami. Okay? Or white communicating branch. Rami is just, ramus is singular. Ramus. So it's white communicating ramus. White ramus. Okay? And then the one that comes out of the chain and then goes back to the spinal nerve so that it will go to the body part, that is gray. It's not myelinated, so it's a gray rami, communicating rami. Okay, guys? For communicating ramus. Gray ramus. Okay, guys? Do you see that? So you get the sympathetic chain on either side, which is parallel to the vertebral column. Okay, and these neurons that control the sympathetic nervous system will go into synapse there first. So the first branch is myelinated, so it's white, and then the white communicating ramus, and then the other one that comes out of that sympathetic chain, going back to the spinal nerve, is gray. So it's not myelinated, okay? So it's got gray communicating ramus. Okay, so you gotta know that. So major spinal nerve plexuses, remember we talked about it. It's only on the ventral, branches, or the anterior branches. But also not just the anterior branches, but where it's supplying. Okay, the busy end of the body is down in the legs, up here by the arms. So
So that's where you have the cervical plexus up here, the brachial plexus, right? And then here you got the lumbar and the sacral plexus, and you know, and the coccygeal. Okay. C1, C4. And C4 is dynamite. You know C4? I couldn't resist. Okay. So
well, the phrenic nerve kind of C3 to C5, okay? Really the major nerve
that comes out of the cervical plexus, okay? But it borrows a little bit of the brachial, okay? So don't worry about that. But we will associate it mostly with the cervical plexus because phrenic. P-H-R-E-N-I-C. What does it control? What does it sound like? Diaphragm. Okay, for breathing. Okay, because I will need you to know each of these plexuses and the major nerves that come out of each. Okay? All right, very good.
So C5, okay, to T1.
That's the brachial plexus. Brachial plexus controls the arm. You got a question, Andre? No, you're good. Very good. So, as I saw your hand kind of go up, I was like, okay, good. So, C5 to T1, okay, those kind of somewhere up here from the neck to just the first T1. Okay, that's the one that's taken up by the brachial plexus. It controls the arm. And then there's a bunch of nerves that come out of this one, right? Okay, you need to know them. So the radial, the ulnar, the musculocutaneous, the median, okay, and the axillary. Axillary is the armpit area, okay? Because the armpit has got quite a few things going on there, sweat glands and whatnot, right? So, from each of these nerves, plexuses, I need you to know the nerves, the major nerves that come out of the plexus. And for the most part, these are controlling the busy parts, the hands and the feet. Okay? So the names of these nerves will have something to do with the hands, like radius. Remember the radius from the skeletal system, the ulna, remember that? Okay, so if I say name a few brachial plexus nerves, you'll be able to do that without a problem. Just think of your forearm, right? Okay, then you just have to remember median and musculocutaneous, okay? But you can at least remember the axillary, because axillary is armpit. It's right by your arms. This number is what, L1 to L4?
Yes.
Yeah, that's what it is.
Okay, so that's the lumbar region, lower back. Okay. And you know, this kind of overlap a little bit, you know. Okay, so L4 to S4, that's the sacral. Okay, what did we say? Lumbosacral, because they don't join together, you know what I'm saying? Because they give rise to nerves that control the legs, like the tibia, tibula, fibula, and the femoral, all right, and obturator. Yeah. Actually, this not this. It's the median. It's the the final one that joins to form the sciatic nerve. Common fibula. Is it common? Okay, common fibula. Okay, very good. That one and the tibia form the sciatic. Remember the sciatic that I'm always showing you in the legs? That's that one. Okay, very good. So, gotta know these ones that arise from the lumbosacral region, which is really the sacral and the lumbar region joined together. All right, the coccygeal is S5 to C0. There's only one coccygeal, so that's that. Okay. So this is the common fibula, and the tibia make up the sciatic, and then the other one is the obturator and the femoral. Okay, so gotta know all those, all right? And the major nerves coming out of these flexors. Okay. So by definition, these are plexuses. You know, they're complex networks from different, parts of the spinal nerve that are formed by the anterior branches or the ventral branches of spinal nerves. Okay, and you gotta include the anterior branches. So brain function, structure and function. The brain is located in the cranium, right? In the skull, right? Okay, the function of the brain is really the control center, right? Intelligence, memory, all those things, right? And we got the brainstem, which is the medulla oblongata, midbrain, and pons. Well, the pons should be in the middle here. And we'll talk about each one. The cerebellum, cerebral hemispheres, cerebellar hemispheres, and the vermis that connects the two. All right? And then the diencephalon, which is mostly made up of the thalamus, right? And hypothalamus. And also the subthalamus and epithalamus, so we'll talk about those. Okay? And this is the cerebellar hemispheres and the vermis. Because it looks like a worm, okay? Vermin. Vermis. V-E-R-M-I-S. Alright? And then the cerebrum, it's got the cerebral hemispheres, okay? The left and right side of the brain. It's also got the cortex on the outside, and the medulla on the inside with the white matter, which are the tracts. The cortex is gray matter that has all the cell bodies, okay? So that's that. And we'll talk about each part and subparts and their functions, right? So that's the brain right there. So the major components of the brain, of course, are brainstem and so forth. So the brainstem, we know the components, right? So the midbrain is up at the top, and the pons is in the middle because it's like a bridge, and then the medulla oblongata, because it's kind of long, it's oblongata, it's kind of longish, and it's continuous with the spinal cord. The brain tapers into the spinal cord. And it's kind of like an integration center. It really joins the top parts of the brain to the cerebellum, and the top parts of the brain, it joins that, and the lower parts, the spinal cord, that's what it does. Remember, we talked about how the brain is like an ice cream cone, with the brainstem being the cone, and then the cerebral hemispheres being the ice cream. Okay, so those are the general functions there. Of course, the characteristics. It's got those squiggly worm-like appearance. The bumps called gyri, right?
In the brain cell?
On the brain. Oh no. Crap. I'm thinking cerebrum already. Yeah. My God, I'm really speeding it up. Thank you. No. Yeah, no. This has got it's anterior to the cerebrum. Okay. The cerebellum is there. You got the brainstem here. Okay. And then the cerebrum over there. Okay. And it includes the midbrain, the pons, and the medulla oblongata. All right. So now we need to talk about the functions of each of those parts. All right. All right. Good. So the medulla oblongata is it tapers into the spinal cord. All right. And it's got the medullary nuclei that control things like breathing. Okay. Blood vessels. Okay, the vasomotor center is located in there, and then swallowing,
coughing, some of those non-vital functions, sneezing, okay, and then also does balance as well, okay. And then the pyramids, that's where you get the decussation or the crossing of the fibers from the right side of the brain controlling the left side of the body, and from the left side controlling the right side of the body. Okay, so there's a crossing. So these are tracts, motor tracts going up and down, and sensory tracts going to the brain. Okay, and they form a cross. Okay, so the pyramids there. Okay, and to do with motor function as well. All right. So just know the basic function of the medullary nuclei. Okay, so these are just parts of the medulla, you know, groups of neurons that do stuff. And they're called neurons, right? Nuclei. Whenever you're in the central nervous system, groups of neurons are called nuclei, right? So the pons, so this is the most inferior, okay? And this is in the middle of the midbrain and the medulla oblongata, all right? And then the pontine nuclei also kind of control breathing, okay? And then it controls other functions as well, such as breathing rate. What's that?
Swallowing.
Yeah, swallowing. It is some of the same functions as the medulla oblongata, okay? But here it kind of controls breathing rate more than any, or the depth of breathing. And this kind of controls the breathing rate, all right? All those pontine nuclei. Okay, so gotta learn all those functions. Okay. All right, and then the midbrain. This one is a little busy. All right. It's between the diencephalon and the pons. Okay, so that's where it is. So that is pretty much location. And then it is the corpora quadrigemina, right? The midbrain, which is made up of the superior colliculi. Okay, this is for vision, reflexes, right? Okay, and then it's got the inferior colliculi. So there's two little bodies or little heels. Colliculi is a little heel, and then the inferior colliculi, which does what? Hearing, right? Okay, so then it's got these parts that are named because of their color. And the substantia nigra is a black substance because of the metabolites for dopamine, which are black. Well, you know, they're not black, but the melanin in there is black because melanin protects those metabolites. They are very reactive. They can damage the brain tissue. So you have a lot of melanin in this nuclei, which makes it black. So, and it deals with motor functions. Okay, it's also involved in Parkinson's disease because it cancels unnecessary motor activity. And then the red nucleus, also involved in motor activity. It is pinkish in color because of a lot of blood vessels in there. Okay, all right. So and then so that deals with motor function. All right. So I need you to know these functions of each of these parts of the brainstem because sometimes I may ask a particular part, you know, multiple choice or anything like that. And say, what does it do? What's the function of this pons or the midbrain and so forth and so forth. And then cerebral peduncle pretty much connects the cerebellum to the upper parts of the brain. These are kind of sort of descending tracts as well. Okay, good. So each of the parts of the brainstem, know the functions. Then we split the brainstem into these three parts, but scattered throughout the brainstem and going a little bit into the diencephalon is a system. So this will be the brainstem like that, right? So the reticular formation kind of goes like this and kind of goes like that. It's joins a whole bunch of nuclei, a whole bunch of parts of the brainstem, and it's called the reticular formation, and it's involved
in you know, basic activity like anything cyclical, like walking and things like that, you know, chewing and things like that, anything that has a cyclical nature to it, that has a repetitive motion. So that's the basic function of it, all right? So the location is in the brainstem. It's scattered throughout the brainstem and borrows a few parts of the diencephalon, okay? And then, you know, like I say, it's mostly involved with activities of a cyclical nature. Anything that is repetitive, cyclical activities. Like when I'm walking, for instance, walking is a good one because it's a repetitive motion of putting the one leg in front of the other. So things like that. Okay, so that's the basic function of the reticular formation. But within the reticular formation is a special section, the reticular activating system, that is involved in sleep-wake cycles. Okay, it produces melatonin as well, and you know it's involved. It arouses the body, arouses cerebrum, the brain, to wake up, really, to go into a state of wakefulness, right? So in the morning when you're a little groggy, you know, your reticular activating system isn't quite waking you up yet. Afterwards, you come to and you're up. So that's the basic functions of this particular part of the reticular formation. Okay? So, gonna know that. So, the cerebellum again is the same thing. Like I said last time, it means little brain. Okay? And it is the same deal. The cerebellar hemispheres connected by the vermis. Okay? And it's got the cortex on the outside, which has the cell bodies, and then the white matter on the inside. And the white matter is one that's arranged like a tree. That's what's called REVIEW-Tue, right? Like arboretum trees. Okay? And it's involved in complex movements, really. You know, awareness of body parts. Okay? You know, in space, you know, where they are. And the cerebellum deals with that, okay? But it's split into these three parts with specific functions. This one, the flocculonodular lobe, deals with vision, you know, flocculonodular, okay? It deals with vision and so forth, and balance, because vision is required in terms of balance, actually, when you're balancing stuff. And because this cerebellum is involved in learning complex activities. Okay? And the vermis is learning complex motor activity. Complex motor activity, right? Okay? So that's what is involved. And the vermis joins the lateral hemispheres, okay? Which are like, you know, the cerebrum. Like the cerebral hemispheres in the cerebrum, okay? So, and these are complex planning, you know, and things like learning to ride a bike, you know, learning to dance, all those things, you know, and practice and complex movements, right? Dancing and things like that. The lateral hemispheres do that, all right? So when you learn to ride a bike, it's your cerebellum. Okay, so gotta know all these functions of these parts, all these parts of the brain that are divided up. In the diencephalon, it's got the thalamus. Remember, the thalamus is what we said is the all sensory information go through the thalamus except the sense of smell. Okay, so it's kind of like an integration center where kind of, you know, sorts out information and relays it. It's like a relay center. It will relay the information, sensory information, to the correct part of the brain that takes care of that particular function, okay? So that's what that does, okay? And the subthalamus is also kind of involved in motor functions here, okay? You know, this is like a relay center, the basic functions of it, okay? And then it looks like a yo-yo. It's got two lobes, like that, okay? Connected by the interthalamic adhesion in the middle, right? So those are the characteristics of it. Okay, and the subthalamus is under the thalamus. It's immediately under the thalamus. Okay, it has all these motor functions as well. The epithalamus, it's kind of above. Epi means above. It's above, superior, and posterior. So it's above and to the back of the thalamus. Okay, so it will be kind of located here. Okay, and this one has got two parts. The epithalamus is got the alveolar nuclei. The alveolar nuclei that is dealt with the emotions, to do with smell. Then we were talking about number 2 the other time, remember? Okay, and then the pineal body, which also produces melatonin, is also involved in puberty, you know, things like that, okay? But it kind of sort of regulates the sleep-wake cycle as well. The pineal body does. Because I'm going to need you to know these functions for each of these parts. The hypothalamus is like the visceral control center. Viscera controls all the autonomic control center, all the autonomic nervous system. You know, it controls that. The hypothalamus is way under the thalamus, hypo under the thalamus, okay? Below the subthalamus, okay? And it deals with a lot of things, like hunger, thirst, pleasure, and it also controls emotions, emotional experience from sensory information. It controls blood vessels, it controls everything. This controls most of the homeostatic functions of the body, the hypothalamus does. Okay? Also controls the endocrine system, because it releases hormones that do that. So gotta know all that, okay? Ooh, my God. Cerebellum characteristics, this is, you know, it's got the lobes that are named after the bone under which it occurs, all right? It's got the 2 hemispheres. This is when I should be talking about the gyri, okay? My good friend. I was trying to rush because the time is going here. Okay, the gyri, which are the bumps. Okay, now I'm correct on this part, okay? Okay, not the brainstem, okay? But the cerebrum. Okay, those are the bumps. Okay, those quickly worm-like bumps on the brain. Okay? Okay, and then we got the sulci, sulcus singular, gyrus singular, okay, which are the grooves that snake in between these bumps on the brain. Remember, the brain looks like it's got a worms on top of it. And the sulci. So those are the characteristics. And then, of course, the longitudinal fissures, like the longitudinal fissure, right? That crack in the middle that separates the left and right side of the brain, okay? Those are them. But the lobes, you gotta know the functions of the lobes, the frontal lobe, things like aggression and things like that, okay? And this is, you know, touch. The parietal lobe is like right here under the parietal bone. Touch, temperature, things like that, okay? It also deals with taste a little bit. So anything to do with touch, you know, pressure, you know, and things like that. The parietal. And then the occipital is vision, okay? The temporal, it deals with smell as well. It deals with hearing. Okay, it's like right here. Okay, and then, you know, things like, you know, abstract thought. So abstract things are kind of like, don't have like a physical existence. It's things like in your brain. Abstract thought, it's processed by that. Okay, and so forth. Sometimes in the exam, multiple choice, I'll say, okay, these are the functions of this lobe, and then you pick the lobe, okay? So gotta know that. And then the insula does taste, and it does also the autonomic nervous system functions to do with the viscera as well, okay? Which are soft internal organs. Okay, so gotta know the lobes, gotta know the functions of the lobes, okay? I'm trying to kind of finish out this here. And then the gray matter, of course, is on the outside, which is the cortex. The white matter is on the inside. Those are the tracts, okay, that join different parts of the brain. So association fibers connect the same parts on the same hemisphere, okay? These are a little shorter because they connect parts of the brain in the same hemisphere. And commissural fibers connect parts of the brain from one hemisphere to the other hemisphere. They cross. Commissurals connect the two. Like the corpus callosum is a big one. Okay? Okay, and then projection fibers connect upper parts of the brain to lower parts, okay, to the spine and everything. So they cross, and they desiccated the pyramids in the medulla oblongata, okay? Projection fibers. So know these fibers and what they do. And then the basal nuclei is involved in motor activity. You get the cerebral nuclei, which are called corpus striatum because they get striations on it. So you've got the lentiform nuclei and the caudate nuclei, which are involved in motor activity as well. Subthalamic nuclei, substantia nigra, okay, which are involved in motor activity. And this actually involved in the Parkinson's disease, because the shaking disease, because they cancel out unnecessary motor activity. Okay, in the substantia nigra, we saw it before over there in the midbrain. Okay, and then the limbic system is got to do with motion, because it connects a whole bunch of parts, like from the cerebrum to the hypothalamus, thalamus, all those, and all the basal nuclei. Emotions. Think emotions when you do limbic system, okay? Oh my God, we are so behind right now. Okay, so the meninges, of course, they continue with the brain, and then you've got the periosteal layer, which is the periosteum of the cranium, right? Is part of the meninges in the head only in the skull. All right, and then the meningeal layer is the actual part of the dura mater that's continuous with the spinal cord dura mater. Okay, so the dura mater folds into these crevices of the brain, like the cerebral fissure. It folds in there, separates the cerebral hemispheres. That's what makes up the dural folds. The dural folds, when they fold up, they leave a space called dural venous sinus where the blood is. Okay, the blood accumulates in there, and then it goes into the jugular vein to go out of the brain. Okay? So those are the dural venous sinuses, and the cerebrospinal fluid is connected into that at the end. Okay? The arachnoid and the pia mater, so we know about those. This looks like a spider's web. And the pia mater is innermost, okay? And there are special dural folds, like the one that separates the cerebral hemispheres, called the falx cerebri. The one that separates the cerebellum from the cerebrum is the tentorium cerebelli. And then the one that separates the cerebellar hemispheres, the hemispheres of the cerebellum, is the falx cerebelli. Okay, so just to know those special dural folds, all right? And then, of course, the ventricles. I need you to know the flow of cerebrospinal fluid. Remember last time I drew this for you guys? So the lateral ventricles joins to the third ventricle by the interventricular foramina. Interventricular foramina. You can hear me say it, okay? So I'm trying to write fast so we can finish. Interventricular foramina joins the lateral ventricles to the third ventricle. This is 1, 2. And then the cerebral aqueduct joins the third ventricle to the fourth ventricle, okay? And then this is the central canal of the spinal cord, right? Okay, so this is the fourth ventricle. And the fourth ventricle has got apertures to the sides and one in the middle, the median aperture. Those 3 apertures connect to the subarachnoid space, right? Okay, guys, this connects to the subarachnoid space. And what's in the subarachnoid space? Cerebrospinal fluid that cushions the brain. Okay? So cerebrospinal fluid that is circulating in the subarachnoid space surrounding the brain will go back to the blood through the arachnoid granulations that go into the dural venous sinuses. You know those dural venous sinuses that are formed by the folds. Okay? I know it's a lot of information, but you know, okay, guys, so know that, and then the arachnoid granulations will deposit cerebrospinal fluid in there. Okay, and we talked about last time, cerebrospinal fluid is made by the choroid plexus, which are lined by ependymal cells, which are those neuroglial cells that form the cerebrospinal fluid. And so the circulation, I just drew it over there. Okay, so that's that. Very good. Blood supply, the brain is 2% of the body, but it takes 20%, which is 1/5 of the circulation, because it's got high metabolic rate, because it cannot store high energy bonds. Okay, so it needs a lot of blood for a small body part like that. Okay, so That's that. And then, of course, the blood-brain barrier, which is formed by astrocytes that surround the capillaries that supply the brain. Okay, so that not anything enters the brain. You gotta protect it. So you have the blood-brain barrier that's formed by the astrocytes. All right, and it protects entry of. And the cerebral arterial circle, which is a circle of blood vessels right underneath the brainstem, which is made out of the posterior and the anterior cerebral arteries joining the internal carotids, okay, that supplies and radiates blood throughout the brain, okay? Cerebral, otherwise also known as circle of Willis, okay? Last one. All right, guys, I know it's kind of fast, but, you know, just to go through this information, I summarized it for you, and then you could go and then look with your notes and see this information, okay? So, 12 cranial nerves, and this is basically the functions of the cranial nerves, right? And I said you need to know the name of it, the Roman numeral notation, and then you got the foramen that it goes through, and the consequences of a lesion when it's hurt, when something's wrong with it, okay? The Roman numeral notation is very simple, and there's two general types, the sensory and motor, of course, for these cranial nerves, just like we have with the spinal nerves, right? And the cranial nerves give rise to the brainstem reflexes. Okay, so olfactory number one. So that olfactory, you know, optic number two, and in that order: oculomotor, trochlear, okay, trigeminal, abducens, facial, what? Vestibulocochlear, glossopharyngeal, vagus, accessory, and hypoglossal. And the foramen that most of these go through, superior orbital fissure. Okay? Except towards the end where you have the jugular foramen and the foramen magnum, like accessory, and you know, and hypoglossal goes through the hypoglossal canal. There's a lot of information, but some of these, the names of it tells you what it does. Okay? This is that most of the muscles that move the eye. Okay, it also controls the constrictor muscles of the pupil, things like that. So that's the parasympathetic part. Okay, the trochlea just controls the superior oblique, which is the muscle that moves the eye. The trigeminal has got those three branches: the ophthalmic, the maxillary, and the mandibular branches that go through the superior orbital fissure, the rotundum, the maxillary, and the foramen ovale on the bottom. Okay, so in the abducens, just controls the lateral rectus, which is one muscle that moves the eye. Basic functions, if you go through these functions, they're all in there. Okay, the facial is one that goes through the internal acoustic meters, remember, and it controls the taste on the front 2/3, the anterior 2/3 of the tongue. Okay, vestibulocochlear is hearing and balance. Okay, vestibule and cochlea. Glossopharyngeal, the pharynx, the which is pharyngeal, the throat area, so it's involved in swallowing and things like that. Okay, vagus controls most of the internal voice. Okay, number 10, you know, so accessory also you know, controls the neck muscles. Okay, sternocleidomastoid and so forth goes through the foramen magnum, you know, and jugular foramen. Hypoglossal, number 12, also controls the tongue and so forth, and the throat muscles and so forth involved in swallowing. So look at those, and then we talked about the brainstem reflexes, okay, which are from the cranial nerves, and the spinal nerves do the spinal reflexes. Okay, it's a lot, but it's only one chapter though. One chapter. Okay, complex reflexes, so we don't learn about the circuitry for that. But things like following your eyes to sudden touch, a flash of light, when you turn your eyes to that, okay, a sudden noise, okay, chewing, consistency of substances, whether it's hard or soft, that's all controlled so that you avoid cracks in your teeth, okay? So all that, brainstem reflexes, following a moving object with your eyes, that's a very complex brainstem reflex. Okay, so for sometimes I might say, give me some few examples of that. All right. So thank you guys. I'm sorry it took a little long, but we went through all the information and the basic stuff. Okay.
Yeah.
Thank you guys.